Now, in terms of importance, the symmetry that talks about y-axis and origin is much more important. X-axis symmetry, like I mentioned, if you have x-axis symmetry, you're automatically not a function. So we're not really that interested in graphs that have x-axis symmetry because in this class we're interested in functions. So I just rewrote the stuff about y-axis and origin so that we can kind of motivate the even and odd. So y-axis said that if you have xy, then you also have minus xy. So this is like saying in comes x, out goes y. And also, if you plug in negative x, you still get the same y, meaning this thing ignores negatives. So this ignores negatives. In the same way that on an x squared, 2 squared gives you 4 and negative 2 squared gives you 4. So whether you plug in the positive or the negative, you still get 4. So for this reason, if you have y-axis symmetry, you will be even function. All right. For origin, if you plug in x, you get y, but also if you plug in negative x, you get negative y. So that's what origin symmetry says. So as example, 2 cubed is 8. Negative 2 cubed is negative 8. So this thing, functions like this, are a function that has origin symmetry keeps negatives, like x cubed. And for this reason, they're called odd functions. All right, so that's my motivation of even versus odd. Here's our actual definition. A function f is even if f of negative x equals f of x, meaning you plugged in negative x, you still got the same output. It is odd if f of negative x is negative f of x. All right, so if a negative inside of my function doesn't change anything, then it's even. If a negative in my function makes a negative overall function, then it's odd. All right, so the difference between the even odd versus the symmetry before is you had to do one test for each symmetry type. For this, there's one test. It's either even, odd, or neither. So I'm going, now just because you have an even power versus an odd power doesn't mean it's automatically even or odd function. So I'm going to do 2 examples. Let me actually write that. So just because just because you have an even or odd power does not automatically make the function even or odd. Okay? So let's look at a couple even odd examples. So determine if the function is even odd or neither. Indicate if there is any known symmetry. All right, determine if a function is even, odd, or neither. Indicate if there's any known symmetry. So for A, let's do f of x is 2x squared minus 1. 2x squared minus 1. So what is this? This is a parabola. It opens up. It's been shifted down 1 and stretched 2. So it should still be even because something like this, right? This should be my graph, roughly. So this should still have y-axis symmetry, which means it's still even. Okay. So my test, I have one test. And actually, I do recommend off to the side, write your negative f. And I only say to do that because sometimes students have a hard time realizing that they do or don't have negative f of x. All right, so my single test is plugging in a negative x. So I get this. But remember, if you square something, it's positive. So I get this expression, that f of negative x is 2x squared minus 1. But that's what I started with. So that equals f. So I plugged in a negative. I came out with the same thing. So this is even. I wrote f of negative x. It gave me the exact function I started with, so it is even. And since it's even, it has y-axis symmetry. So this thing ignores negatives. All right, one more. Let's do f is x cubed plus 2. So I do have an x cubed there, so this is in the running to be odd. Probably not going to be even, but maybe odd. What is this? This is a cubic that's been shifted up 2. Okay, so if I draw a picture of my function, well, it's definitely not even because it doesn't have y-axis symmetry, but it doesn't really seem to have symmetry about the origin either. Okay, so that's not promising. Off to the side, I'm going to write my negative f. So that's minus x cubed minus 2. All right, my test. My test just says plug negative x in. So negative x cubed, well, that's, you can put the negative on the outside. Negative x cubed plus 2. That does not equal f, what I started with, because I was positive. And it also doesn't equal negative f of x, because negative f of x has a minus 2, but this has a plus 2. So it doesn't equal what you started with. It doesn't equal the negative of what you started with. So this is neither even nor odd. And it has no clear symmetry. So there's one test for even versus odd. Plug in negative x. If you get the function you started with, f of x, then you're even and it ignores negatives. If you get the negative of the function you started with, then it keeps negatives and it's odd. If you don't get either one of those things, then it's neither even nor odd.